Alright, so welcome to the video lesson, and in this video we are just going to be solving these tutorial questions. These questions that you can see, this is tutorial 2. They are focused on sets and radicals. We're going to be rationalizing, and I'll be solving all these questions with explanations. Okay, so for you guys maybe who haven't understood how to rationalize, by the end of this video you're going to be able to rationalize, because this video is focused on solving, and I need to let you know about that, because it's not a lesson like teaching you it's from scratch. If you want lessons like where you want to be taught from basic to advanced, make sure that you check on our app or website, A Plus Academy app and the A Plus Academy website. If you don't have them, comment in the comment section or contact me. I give you access. So we have a platform where we've recorded lessons. We've taught all these topics, and on every topic we solve tutorial questions. That's how we teach as A Plus Academy. Every topic we make sure that we expose you to tutorial questions so that you can be very good at math. Okay, so that's why we teach from basic. Okay, like from the basic concept. But for this video we will be just focus on the solving part. So all these questions will be solved one by one, and trust me, on rationalizing they don't go beyond these questions. So if you're able to solve these, trust me guys, you can't fail any question under rationalizing, unless maybe you just make a mistake. Okay, so but even if you don't know how to rationalize, and maybe if you don't know radicals, if you are watching this video, because I'll be explaining. Let's say you've maybe studied the topic, but you're just not clear about how to approach some questions. Trust me, by the end of this video, you're going to reach at a level whereby you can solve almost every question. And make sure that you are solving along. So grab your pen and paper. I don't know if it's a pen, so whatever you're using, but make sure that you are following along for you to enjoy this. So whenever I start solving, make sure that you pause the video, you try, we compare the answers, we move on like that. Alright. So without any further ado, and one more thing, don't forget to subscribe to this YouTube channel. Subscribe for more videos like this. I always emphasize you to subscribe. Don't just sneak watch on this channel and leave without subscribing. That's how you're going to motivate me to make more videos like this, and that's how you also be receiving notifications whenever I upload educative content like this video. Okay, and subscribe to our tutorials in case maybe you are struggling with math in these other non-quota courses. We offer tutorials online through our app and website. Make sure that you contact us if you want to subscribe. Alright, so without wasting any time, let's proceed and solve the question. Solve the questions. Alright, so let's solve the first question. So we're going to say, let's do this. I hope it is clear. So question 1. So question 1 is like 2, 3 minus square root 2 over. So the first question is saying that, let me just show you. So question 1, they want you to rationalize the denominator. Denominators are these below, the bottom part, right? So our focus will be on the denominator part. So let's begin with the first one. Okay, so to rationalize, we're going to, so in this case whereby you just have one thing here, we won't find the conjugate. There won't be such thing as finding the conjugate. Remember, the purpose of rationalizing the denominator is to get rid of this square root or this radical here. So your question should be, how am I going to get rid of the radical? So one of the ways in which you can get rid of the radical is by, the way in which we can get rid of this radical here, which is square root of 3, is by multiplying the numerator and denominator by square root of 3. Okay, so we're going to say times so basically we're just multiplying this throughout, and Yeah, like that. So we're going to say square root of 3. So no need of getting the 4, because we just want to get rid of this. If you remember that when we multiply, if you remember the rules of multiplying radicals, there is a rule that if you multiply a radical and a radical, which are having the same roots, like these two are square roots, they cancel each other. So that's already enough for us to get rid of the radical. And don't take this 4 along. Okay, so we're just going to say this times that is going to be 2. This times this, they're going to cancel, right? So you're going to have 3. Then this times square root of 3 times this part here is going to be negative. Remember, multiplying of radicals, there are some rules when you're dealing with the radicals. You need to understand, actually, for you to enjoy this topic, I want you to take note of this in case you don't understand. You need to understand the rules of adding radicals, the rules of multiplying radicals, and yeah, these two are very important. And dividing is just the concept of conjugate that's important. So let me just quickly walk you through. So when you're multiplying two radicals, now these two radicals, they are both square roots, right? But again, they are having different numbers under them. So listen, if you look at, let me give you an example here. Here we multiplied square root of 3 times square root of 3. They cancelled the square root because they are, first of all, they are both square roots, and secondly, they are both having the same number, which is 3, under the root. Only if that is met, the square root can be cancelled, and this is 3. We will just remain with 3. The square root gets cancelled, and we remain with what is under the root. But if two radicals, whereby both of them are square roots, they are multiplying, but they are having different numbers under them, we just multiply what is under them and maintain the square root. So it's going to be 3 times 2, that is 6, right? We maintain the square root because the numbers under them are different, and here we have 6. So this principle, I mean these basic concepts, you need to understand them as well. Okay, so you need to understand that. Yeah, so we've multiplied the numerator part, and then so now let's multiply the denominator. This times this is going to be 4. This times this will be 3, right? So this is going to give us 6 over, that is 12, right? So now look, by just doing this, by multiplying this with this, and eventually making the square root to disappear on the denominator, we've just rationalized the denominator. Rationalizing means that if they tell you to rationalize the denominator, you need to make sure that eventually you don't have any square root there. If you still have it, it means that you are not done rationalizing, or maybe you've done it the wrong way, or maybe you've made a mistake. Yeah, so now in case maybe they want you to leave your final answer, so sometimes they might tell you to, I want you to take note of this, but there's a question that I'm about to solve. So they might tell you that leave your answer in the format a plus b square root of 6. Leave your answer in this format. So when you reach here, you need to break it down like this. So you're going to say, but for this question, it's like it is just open. For question 1, it is open. You can leave in any format. Okay, so it's going to be, so you are going to do this. So there's a concept in math, that this concept here, whenever you have a plus b over c, it is same as you have a over c plus b over c. Have you seen? So meaning that even here, if I have this, it is same as I have 6 over 12 minus square root 6 over 12. So by just doing this, we have left it in this format here. So this question, I've explained some basic concepts, like I've explained with a question instead of explaining individually. So maybe in the other questions, I'll just be applying them. I won't be explaining from scratch, especially the rules of multiplying and yeah, in addition. Maybe addition I'll explain with a question. Probably there is a question coming where there will be, we're going to add some radicals. I'll explain the concept. So let's go to the next question. Alright, so we have a question here. So this one, we're going to find the conjugate. How do you find the conjugate? By simply changing the sign of, okay, most of the people change the sign of this one, but the concept is this: just change the sign of any of these two, then maintain the other one constant. Let's say if you take x, change the sign of x, and this one just make it be constant. Now some people will tell you that you have to change the sign for the for the radical, and which is what we're going to do. Okay, so I'm going to say, so the conjugate is going to be x. I'll change the sign for this one, for the radical, which is the common way. But even if you do it the other way, whereby you change the sign for x, then this one, maintain it constant, you still get the same answer. That's what I came to figure out. Just that the common way is this. Okay, over x minus square root of y. Okay, so we multiply, so it's going to be, this times this is going to be x power 2 minus x square root of 9. I mean square root of y. Then we say over. Now remember, our goal is to rationalize the denominator. So make sure that whatever you're going to do, denominator part should not have any square root. So let's just expand this. Alright, so let's expand. So we're going to say this times this, x times x is going to be x power 2. X times this one is going to be negative x y. Then we come here, this times this is going to be positive x square root of y. This time this, remember these are similar, right? They are multiplying, so the square root will disappear, the sign will still remain negative, but we're just going to end up with y. Okay, so we now have on the numerator we have x power 2 minus x square root of y over. Now look, these are going to cancel because they are similar, having opposite signs, right? So we are going to remain with x power 2 minus y. So like for this one, you can just end here. They haven't told you to leave in this format, which is this one here. So if they haven't told you, just know that it is like a freestyle. You can just end like this. But if you want, you can do the same thing, meaning that it's going to be, in case they told you, it's going to look like this: x power 2. Like I want to expose you to living in this format, because usually on the exam, even if they haven't told you, they expect you to do this, but usually they'll tell you, especially if it is straightforward like the one that we initially had. But this one, and I doubt if they can tell you to necessarily live in this format. But if they told you to live in the format of a plus b, maybe square root of y, it will look like this: minus xy over x power 2 minus y. Alright, okay, so we have this one: x minus square root of x power 2 minus 9, x plus square root x power 2 minus 9. So this is also, this is the third question from a tutorial sheet. And if you don't understand like most of the concepts which I'm applying, subscribe to our tutorials and access our video lessons on our website and app, so that you can learn and watch at your own pace. Okay, so let's start. So our goal is to rationalize the denominator, right? This one is going to be quite involving, but anyways, so what will be the conjugate? So the conjugate is, just change the sign of this one. So actually some lecturers want you to show them that this is the conjugate. So the conjugate is going to be x minus square root x power 2 minus 9. Alright, and yes, this is what you're going to do. So we're going to say x minus square root x power 2 minus 9, right, over x plus. So right now I'm just trying to multiply this conjugate with the numerator and denominator. That's what I'm trying to do. So I'm just going to say x power 2 minus 9, right? Then we multiply, so it's going to be x power 2 minus 9, right? Then here we have x minus x power 2 minus 9. Alright, so we are going to multiply now. Oh, this one will be involving. So which one, where should we start from? Let's start with the numerator, then we go to the, but another tip that I can give you is to do this. If okay, let me just listen. If they have told you to rationalize the denominator, your focus will be simplifying the denominator. The numerator, if you want, you can just leave it like, you can just write it like okay, let me not do that. Let me not show you the shortcut, because maybe some lecturers would want to see you like expanding both. Okay, but your focus should be denominator. Make sure that there's no square root remaining here, but I'll start with the numerator anyways. So we say x times x, it is x power 2, right? X times this thing here is going to be negative x power 2 minus 9, right? Then this times this is going to be negative x power 2 minus 9, right? And then this times this. So remember, this is having negative, so already the sign is going to cancel, right? And then since these are like similar things, this is like same things are multiplying, so the square root will disappear, right? Both this and this are both square roots, and both of them are having similar things under them, which is x power 2 minus 9. So the square root will just disappear, but we will remain with the same things that are under the square root, which is x power 2 minus 9, right? And then we now go on the denominator. So make sure that you're very fast when you're solving this. I'm just slow because I'm explaining to you. If I was alone, by now I would have been done solving this. So let's say this times this is going to be x power 2, right? This times this is going to be negative x negative you know, these things can be confused as well. So if this is going to be x power 2 minus 9, right? Then we say this times this is going to be plus x power 2 minus 9, and then this times this is going to be negative. Since they are similar things, we're just going to end up with whatever is under the square root, which is x power 2 minus 9. Right? So let's see what we can simplify. So let's start with the numerator. Let me just put an equal sign here. So with the numerator, let me first write x power 2. Then you know that this and these are similar things. They can be added. Since both are negatives, like this thing here and this thing here, these two, they are like terms. So we can add them, and it's going to be negative 2x negative 2x x power 9 and plus x power 2 minus 9, right? Right, I hope you are following. So we now go to the denominator. So we simplify. You know that this thing here and this thing are like terms, and they are having different signs, so they are going to be cancelled out, right? And what are we going to remain with? We're going to remain with x power 2, right? This negative we multiply it throughout, and it's going to be negative x power 2. I mean, we expand minus no plus 9, because negative and negative will be positive. So now let's sum up the numerator now. X power 2 plus x power 2 is going to be 2x power 2, right? And then we are going to remain with negative 2x x power 2 minus 9, and then minus 9, which is this one here, and then we say over. Now this and this will be cancelled, right? And what have we just remained with? We've remained with 9. We can try to arrange them in order whereby we put this at the end, the square root thing. Then we're going to have 2x power 2 minus 9. You don't necessarily have to do this, but I'm just doing it because I want to show you something at the end. Like for this question whereby they haven't told you to leave it in that format which I'm telling you about, we can just do this. So here we're going to have 2x power 2 minus 9. Alright, and then we have 9 here. Listen, if they haven't told you like no, leave in this format, like leave in the format of a plus b, and so you can just end here. It's okay here. But if they have told you, you can now go beyond. Okay, so let's say they told you that okay, when you expand, you leave in the format of a plus b square root of x power 2 minus 9. What you do is this. You're going to collect them. So you're going to this and this. You're going to, these two are going to collect them like together because they are presenting a. They're going to present the numerator of a, and then using that concept I taught you. When you break this down, you're going to have 2x power 2 minus 9 over 9, right? Minus 2x square root x power 2 minus 9 over 9. So we have left it in this format. Only if they told you, but if they didn't, then it's just a freestyle. If you want, you can reach here or you can just end there. And when the lecturers are marking, if they say that rationalize the denominator, they will focus on seeing how you've handled the denominator. They'll just look at the denominator. Then maybe at the end they look at the numerator, but their focus is seeing you rationalize the denominator. So let's move on to the next question. Okay, so we have this question here, the question which most of the students find challenging. I don't know why it's challenging here. Okay, so let's solve it. So they want you to rationalize the denominator, and they might bring this on the exam. So for this question, what you do is this. You're going to rewrite this. How are we going to rewrite it? So here's how. So we're going to rewrite it like this. So I'm going to do this. I'm going to say this expression here, I can also write it as 1 over square root of 2 plus 1. Okay. And then I say times. If it doesn't make sense, wait, I'll explain. Then say 1 over square root of 3 minus 1. Now, why have I done this? Because this is similar to what I've just written here. But how? If I multiply this, I'm going to go back to what I initially had. Imagine I multiply the numerator 1 times 1. I'll still get back the 1. If I multiply the denominator this times this, I'll still get back what I had. So it's like you split them. Okay? You use what is called the splitting method. I think there's a video on this channel where I solved this question for students of last year, and I hope you guys will understand this. So once you do this now, there is just this rule that as long as the denominator, and let me tell you one thing, as long as you are having a radical on the denominator, whether you like it or not, it's a rule that you have to rationalize. Yeah, so even if they haven't told you to rationalize, it will be happening whereby maybe on a different topic, maybe on GPs, they will give you a question, then you end up with an answer having a radical or a square root on the denominator. Make sure that you rationalize. You also get some marks for just doing that, and they won't tell you, the lecturers. Okay, so let's solve now. So what you're going to do is that you're going to rationalize this and this individually. So let's start with this one. So let's call this part 1, this is part 2. So you're going to say 1 over, this is the first part, 1 over square root of 2 plus 1, right? So what's the conjugate for this one? It is basically So since the majority of you've been taught that you change the sign for the one having the square root, right? In this case. But even if you change the sign for 1, it will still give you the same answer. But for simplicity purposes, I'll just change the sign for square root 2. Because some of you, this is what you've mastered. You've swatted that you change the sign for the one having the square root. But still it works. Okay, so this is our conjugate. Okay, so let me put this in this bracket. Okay, so we come now to part B. Part B as well, we do the same thing. So we say 1 over, what do we have here? We have square root of 3 minus 1. Then we multiply. Okay, so I'm saying that we write like this, and then the conjugate. If you want, you can just change the sign for any of these two. That will be okay, a conjugate. But for simplicity, like I'm saying, I'll change the sign for the one having a square root. Since that's what they have taught you, they have made you to Swatila. Then I do this. Okay, so what you do is that when you simplify this, whatever you get, you're multiplying it with what you get after you simplify this. Whatever you get will be your final answer. So let's do that. So let's start with this. So this part, if we simplify, we are going to have negative 2 plus 1, right, over this time this it will be negative 2, this time this it will be, this time this it will be negative 2, right, this time this it will be plus 1, right. So let me just put it in the bracket. We now come to this second part. So it's going to be negative square root of 3 plus minus 1 over this times this is going to be negative 3. This time this it will be negative square root of 3. This time this it will be positive square root of 3. And then this time this it will be just plus 1. You can do this. Alright, so this one we just maintain it the way it is, plus 1, and then this and this will cancel, right? So we remain with negative 2 plus 1. We put in the brackets, the square bracket, and then we come here. Numerator is going to be 3 minus 1. So this and this will cancel, right? And we have negative 3 plus 1. Right. So here we have negative 1. And let's just put it in brackets again. And here we have, because we're going to multiply with this one when we're done. So you're going to have negative square root of 3, negative 1 over negative 2, right? And then so if we divide this into this, we're going to eventually have, well, let me just okay, let me do this. I'll do this. Let me just say, let me just write them like this. Negative 2 and negative square root of 2. This is negative square root of 2, right? Plus 1 times, I've cancelled these guys, times what is on the numerator here. So like multiply the numerators and the denominators individually, then we simplify. You can use any method that you're comfortable with. This will give us positive 2. Now multiply the numerator. So this time this it will be negative, no, positive 6 square root of 6. This is going to be plus square root of 2. Then this time this it will be negative square root of 3, negative 1 over 2. Yeah, so for this one, there's no way in which we can leave it in the form of a plus b. This is the way, or this is the way you can just approach this question. Now listen, I know you might be thinking, why can't we add these? These are unlike terms. Why are they unlike terms? Because of course both of them are square roots, but for the fact that they are having different numbers under them, they are unlike terms. We cannot add them up. You can only add if they are like terms. Okay, so let's go to the next question. Alright, so let's solve this question. So this question, they want you to rationalize the denominator likewise. So the conjugate, you just change the sign of what is here, right? So you're just going to say times 3 plus 2 square root of 3 over 3 plus 2 square root of 3. Then you say 5 times this is going to be 15, right? 5 times that is going to be positive 10 square root of 3. And then 3 times 3 is going to be 9, right? And then 3 times that is going to be with 6 square root of 3. And then this times this is going to be negative 6 square root of 3. And this times this. So the sign is going to be negative because we have a positive there. And then 2 times 2 to be 4. And then this time this to give us just 3, right? And then on the numerator we're just going to have 15 plus 10 square root of 3, right? And then this and this will cancel out. On the denominator we're going to have 9 minus 4, 3, like this, right? So we have 15 plus 10 square root of 3. Then we have 9 minus 12. 9 minus 12. Alright, so this is what we are having right now. So let's proceed with the simplifying. So what is 9 minus 12? 9 minus 12 is negative 3. So first you write the numerator. So we have negative 3. Okay, so this is negative 3. So if you wanted you to leave it in this format of a plus b, maybe I'll try to be a little bit fast since you've understood by now most of the basics. So we can leave it like 15 over negative 3 and plus 10 negative 3, which when you simplify are going to have negative 15 over 3 minus 10 over 3. If they wanted you to leave it in this format, but for this question they haven't said that, so we can just end where here. Alright, hope you've understood that. So let's proceed to the next question. So the next question, they want you to rationalize the question which is right here. So they want you to rationalize the numerator in each of the following. Have you seen? They want you to rationalize the numerator. Now numerator, it is the top part. So our focus is to make sure that the top part, I don't know what the other way I can use, but you know what the numerator is, right? The numerator is not eventually having any square root or any radical. So let's start with the first question. Alright, so we are going to multiply with the conjugate of the numerator. What will be the conjugate in this case? Let me show you the question how it is phrased. So the question is phrased, rationalize the numerator in each of the following. I've forgotten if I've showed you guys. Okay, so the conjugate is going to be, you can change the sign of the square root, or you can just change the sign that is here. So I've changed it to negative 5 plus h minus 3, 6 times over minus 3. Alright, so let's proceed. So we're going to say this times that. Okay, let me first write them properly. So basically we're just multiplying the 5 plus h minus 3 with the negative 5 plus h, right, over h negative 5 plus h minus 3. Alright, yeah, so we can now simplify, but I'll start with the numerator then denominator in that manner. So this times this is going to be negative. Since both are square roots and they're having same things under them, we're just going to get rid of the square root and remain with 5 plus h, right? And then this times that is going to be negative 3, then square root of 5 plus h, and then we come to this one here. So negative 3 times this is going to be negative, no, this sign they are going to cancel, so we are going to have positive, then that one there is going to be we just write 5 plus h, and this time this it would be plus 9 over negative h 5 plus h minus 3h. Alright, so we cancel this and this because they are having different signs and they're like terms. So what have we remained with? We remained with negative 5 plus h plus 9 over negative h 5 plus h negative 3h. Okay, then we have negative 5 negative, expand this, negative times 5 negative times h, you get this, and we say plus 9 over, what do we have here? We have okay, I don't really see the necessity of even expanding the denominator, but anyways, let's just do it. Okay, but the denominator, it looks nice if it is in this format, but anyways, since our goal is to solve, I don't see the necessity of expanding the denominator. So let's just simplify the numerator part. So okay, I'm going to simplify this. So here I'm having negative h. I'm going to have positive 4, right, over, okay, now let me just factorize h on the denominator, because mathematically in this situation we just have to factorize the h so that we can at least end up with sensible stuffs. Okay, listen, we're just trying to simplify right now. Okay, we're trying to leave our answer in the simplest format, so we can factorize negative h. We have 5 plus h plus 3h. So this negative, we can divide it into the numerator. Like, I'm just trying to simplify. So if we divide this negative into the numerator, you're going to have h minus 4. This is mathematics, guys. We eventually end up with, okay, listen, you can just, like, as long as you've left it in simple format like this, have you seen? If you want, you can just end here. Yeah, right now I'm just trying to simplify. simplifying is like a freestyle. Lecturers are interested in seeing you reaching here, whereby the numerator is rationalized. So let's go to the next question. Alright, so let's find the conjugate. It's going to be square root of 3. Let's change the sign of anything, but in this case just change the sign of what is between, or if you want you can change the sign of this one or this one, but let's just change for this one. Look, the purpose of the main logic behind the conjugate is to change the sign of one thing, maintaining the sign of the other thing constant. As long as you do that, you'll still end up with the same answer. It's just that the majority, we have just mastered that you change the sign for the radical, or the one which is the square root. So we have 5. So we're going to multiply this throughout. Okay, so we're going to say this time this is going to be 3, right? This time this is going to be negative. So we multiply things under the radical. Since look, oh, sorry. So I'm saying that this we've multiplied this times this, the square root has disappeared. Then we multiply this times this. Since they're having different things under them, we're just going to multiply what is under them. So it's going to be 3 times 5 basically, that is 15. And then we multiply now, come now to this. So this times this is going to be plus 15. Then this time this is going to be negative 5. Since they are similar stuffs, the square root is going to be cancelled out. Then here we're just going to have 7 minus 5. Okay, so let's simplify the numerator. So this and this will cancel out, right? What are we going to remain with? We remain with 3 minus 5. 7 square root of 3 minus square root of 5. So 3 minus 5, it is negative 2. Okay, so for this one, okay, we can just end here. And this is just one to simplify. Or maybe if you want to go further, you can just say negative 2, 7, 3 minus 7, 5, right? Yeah, you can end here if you want. But as long as you showed them this part, then you're good to go. Alright, so we have a question here. And the question is saying that, okay, let me just rewrite it again. So x power 2 plus 1 minus x. Yeah, so they want you to rationalize the numerator. Now they have just given you this, but how do you know that which one is the numerator? So just know that behind the scenes it's more like this over 1. Okay, so mean that behind the scenes there is 1 as a denominator. So what they have given you is a direct numerator which they want you to rationalize. So now find the conjugate. So we just say times okay, I'll change the sign for this. Let's this time change the sign for, okay, this time let's change the sign for the, like I want to try to change the sign for x, then so that you guys can see that it's not always that you have to change the sign for, it's not always that you have to change the sign for the one that is having the square root. Okay, so this time change the sign for this one. As long as the sign for this is maintained constant, then we are good to go. So I'll just write x power 2 plus 1 plus 1, then say plus x over plus x. Right, so we are having x power 2 plus 1 minus x being multiplied with x power 2 plus 1 plus x over plus 1 plus x. Yeah, so the numerator don't need to even do anything. We've already expanded like that. Let's come to the denominator. So let's come to the numerator now. So this times this, since they are similar, we are going to end up with x power 2 plus 1. This times that is going to be plus x power 2 plus 1. And then this times this is going to be negative x power 2 plus 1. And then this times that is going to be negative x power 2 over x power 2 plus 1 plus x. So we say x power plus 1. You know that this and this can be cancelled, right? Because they are like terms having different or opposite signs. So we can cancel this and we have negative x power 2 over square root of x power 2 plus 1 plus x. And this and this will cancel out, right? And we are going to have 1 over plus 1 plus x. Yeah, so you can just end here. We can just end here. I hope we haven't made any mistakes. Okay, so let's go to the next question. Alright, so we come to 2. So this is saying that express this in form of a plus b, where a and b are rational numbers. Okay, so these are the types of questions I was telling you about. So first we are going to solve 2. Then b is saying that this is 2a. Then 2b is saying that express this in the form of a plus b square root of 3, where a and b are rational numbers. Simple, right? So let's solve the first one. Right, so now let's solve this question. So they want you to leave this in the form of a plus b. So now, when they give you like this, then you see that there is a square root and it is having a number under it like this. Just know that when you simplify, you should end up with square root of 3 somewhere, like in your final answer. If you end up with maybe square root of maybe something bigger, try to find ways to simplify it. So how do you solve this question? There's a rule that if the radical is a denominator, if on the denominator you have a radical, you have a square root, a cube root, it has to be rationalized. That's the rule. So what I'm going to do is this. I'm going to take this alone, okay? I'm going to simplify it. I'm going to apply the rule. Like that's the rule whenever you are dividing the radicals. If there is a radical in the denominator, rationalize. Whether they have told you or not, it has to be rationalized. It's like a principle as well. Okay, so I'll get this alone. Then when I'm done rationalizing this, that's when I'll come back to add it to this square root of x and negative 1. I hope that makes sense. So I'll write it independently. Plus 1 over square root of 3. Right? Then we multiply with what's the conjugate of the denominator? The conjugate of the denominator is, so just change the sign of what is between if you want, or if you want, change the sign of this, but I'll just change. I'm sure by now you've understood the logic, so I'll just change. Let me just change the sign. So I'm using the conjugate of the denominator, right? So I'll just change the sign of what is between so we'll change it to plus 1, then it's the bracket, then we multiply through. So it's going to be, this time this is going to be 3. Okay, so it's going to be 3, and then this time this is going to be plus square root of 3. This time this is going to be square root of 3. Yeah, this, let me just go through. This time this, okay, that time that, okay, that time that, okay, and then this is 1 times 1, it will just be 1. Let's go to the denominator. This time this is going to be 3. This time this is going to be, this time this is going to be negative square root of 3, then negative 1, right? So 3 plus 1 is going to be 4, right? This plus this, remember the addition of radicals. If these are the same, they can be added. So this is going to be plus 2 square root of 3 over 3 minus 1, that is 2, right? These are going to be cancelled. So now, remember, we need to leave it in this format. And remember the concept I showed you, that whenever you have a plus b over c, you can write it as a over c plus b over c. Remember that, right? So we're going to split this by writing them like 4 over 2 plus 2 square root of 3 over 2, then simplify the 4 into 2. 2 into 4, it is 2. 2 into 2, 1, right? So we just remain with 2 plus square root of 3. Now I've just simplified this. I just took this alone. After simplifying it, I've ended up with this. So I'm going to get my final answer and add it to these 2 which remained. So I'm going to have 2 plus square root of 3 plus 3 minus 1. So 2 minus 1 is what? It is 1, right? Square root of 3 plus square root of 3 is going to be plus 2 square root of 3. So just like this, we have simplified the first one. Let's go to the second question. Okay, let's look at B. So they just want us to express this in the form of a plus b square root of 3. Alright, so find the conjugate. What's the conjugate? Conjugate is 3 plus 2 square root of 3, right? And alright, so 5 times this is going to be 5. 3 plus 2 square root of 3, and we now multiply the denominators. So the denominator with the conjugate denominator, that's what we can call it, right? So we say 3 times 3 is going to be 9. 3 times this is going to be, so basically there we're just having plus, just having a 3 times 2, it is 6. 3, then now we also write the square root there. Then we come here, this times this is going to be negative 6 square root of 3. Then this times this is going to be negative 4 square root of 3. No, my bad. Sorry, this and this, the square root is going to disappear, right? I thought there is no square root there. So basically we're just having 3 here, and then we are going to have that one. I'll just expand it later. Okay, let me expand it, since we are supposed to leave it in that format so that we can remove some work. So I'll have 15 plus 10, then over, so this and this, they are going to cancel each other, right? Then we have 3, we have what do we have? We have 9 minus 4 times 3, it is 12, right? So we have 15 plus 10 square root of 3. Then here we have negative 3, right? So since we're supposed to leave it in that format, we're going to split this. So it's going to be negative 15 over 3 minus minus 10 over 3. Okay, so 3 into 15 which is 5, right? So we can say negative 5 minus 10 over 3, square root of 3. So this is our final answer. So in case they ask you, what is your A? What is our A? What is our B? Look, they told you to live in the format of A plus B square root of 3, right? So whatever is coming in front of 3, it is B. Whatever is here is A. So A is simply negative 5, then B simply negative 10 over 3. Trust me, I once saw this question in a certain past paper and students were confused. They were like, how can I find A and B? But I had already taught them this. When all you had to do is to just identify your A and B. And they started panicking. No, you haven't taught this. You have never taught this one, Joseph. This is new. I've never seen this question before. Like, you guys like memorizing questions. So let's go to the next question. So here they're just telling you that write each of the following in terms of I. Perform the indicated operations and simplify if possible. Look, I just want you to write this info. So before I solve this question, let me introduce you to some of the concepts. So this question is like a bonus question for this tutorial video. Like for you to reach this far, I'm giving you like a bonus. I'm giving you a gift. This should fall under complex numbers. Don't worry, it's a simple concept. Yeah. So let me first introduce you to a certain concept. All right. So I want you to understand this. Whenever you have a negative under a square root, let's say negative 1, this is a complex number. It can also be written as square root of 1 with a letter I. Okay. This also means that if you have, let's say, square root of negative 5, it is same as you have square root of 5 with a I. It's like this I is carrying this negative which is here. Whenever you write it, and you write it outside, not under the root, outside. Okay. So now, you know that this one again, there's a concept that I want to introduce you to. You know that square root of 1. So take note of this concept 1. Take note of it, and then the second concept is this. You know, let's come back here. You know that square root of 1 is what? Square root of 1 is 1, right? So we can simplify this as negative 1. Square root of negative 1 is equal to I, right? Let's say we want to get rid of this square root here. We introduce power 2 to both sides, right? So we eventually remain, so this square root will cancel, right? And we remain with negative 1 is equal to I power 2. So this brings another identity, which is whenever you have I power 2, it is same as you have negative 1. So as you'll be simplifying, if you end up with I power 2, substitute with negative 1. Now, if you have understood this, we can now proceed to solving these questions. So, question A. Question A is like this. They're saying negative 4 times, square root of negative 4 times square root of negative 16. Okay. So, let's apply the concept that I initially showed you. So, as long as we have a negative under the root, we can also write this as 4i times 16i. Have you seen? So now that we have gotten rid of the negatives, we can now apply the concepts that we know. So we've remained with square root of 4. What is the square root of 4? Square root of 4 is simply 2, right? So we have 2i. And square root of 16, it is 4, right? So times 4i. Now, 2 times 4, it is what? 8, right? I times I, it is I power 2. Now remember, I told you that whenever you have I power 2, it is same as you have negative 1. So the final answer is negative 8. Now I want you to try this out. Comment the answer write your answer, your final answer in the comment section. Okay. Yeah. So you're going to do this. So question B is like this. Negative 25 times, square root of negative 25 times square root of negative 9. Write your answer in the comment. Just write that, okay, my opinion on B, question 3B is this. Alright, so now let us move on. So we have AB, so let's go to C. So C, we have square root of negative 36 over square root of negative 4. So let's write them to complex numbers. So basically we have square root of 36i over square root of 4i, right? And what is the square root of 36? It is 6. Square root of 4, so we have 6i. Square root of 4, it is 2, so we have 2i, right? So 2i into 6i. If you want, you can rationalize this, but it's like a waste of time. You still end up with the same answer. So this I will be cancelled, right? Then 2 into 6, it is 3. We come to D. D, we have negative 64 over square root of negative 16. And what are we going to have here? So what's this? So first we write them in complex number, as in complex form. So we have 64i over square root of 16i. Then what is the square root of 64? It is 8i over 4. Square root of 16, it is 4i. Then 4 into this is going to give you 2. Yeah, so this is just like a bonus knowledge. Alright, so I hope that you understood, and don't forget to subscribe to this YouTube channel. Like, don't even feel greedy. Just give me that subscribe. I deserve it. For the fact that you've watched this far, you need to give me as well. I've given you the knowledge. In return, give me the subscribe. Just kidding. But yeah, I deserve that subscribe. And share this video to your friends. Share the YouTube channel to your friend. And watch more videos on this YouTube channel. And don't forget to subscribe to our tutorials. Contact me on plus 260, plus 26 then 0. Okay guys, you know how to write these Zambian numbers. So plus 260 777 25414. So contact me on this line if you want to subscribe to our tutorials. We have a platform, we have a website where you find organized video lessons. We've taught biology, physics, chemistry, and math in order. Okay, so you just watch at your own pace, and you catch up in case you are behind or you want to go ahead of the lecturer. We've taught for the whole syllabus for NS, for A-level O-level courses. I don't know if I should say subjects. NS, we've taught everything. PH110, MA110, CH110, and BI110. So make sure that you subscribe, then you access our video lessons. Imagine every topic I teach like this. Every topic I expose you to these kind of questions. Like, how can you fail to get an A+? That's why all my students who are committed, who make use of my materials, they get distinctions, because it's impossible to fail, trust me. So this is the way that we teach as A+ Academy. We expose you to tutorial questions, and in case maybe you want the solutions like the solved ones, the unwritten ones, we also have them on our platforms, on our app, and on our website. I'll put the link in the comment or in the description. Make sure that you create an account and be able to access our videos.